when we have a right square base pyramid such as this one, we can work out the surface area with this formula, provided we know the base side length and the height of the pyramid. And in our example here, we do have the base side length and the height. So let's proceed with working out a value for the surface area of the pyramid. So we have 4 squared plus 2 times 4, and this is multiplied by 4 squared over 4 plus the height squared, which is 6 squared. So we have 16 plus 8 multiplied by 4 squared over 4 is actually just 4. This is adding on to 36. So moving on a bit more, we have 16 plus 8 root 40. 8 root 40 is 50.6 to 1 decimal place. So adding them together, we get 66.6 centimeters squared. That gives us a value to 1 decimal place for the surface area of this right pyramid, with the surface area being the area that covers the base and the 4 triangle side faces. And if you're still watching and wish to know where this formula comes from, we'll look at that now on the next page. So the first step in seeing where this formula comes from is to think about how the surface area of pyramids such as this one is made up. It's made up from the square base plus 4 equal-sized triangle faces. And the one thing we have here that we didn't have in the first example is the slant height of a square pyramid. This is the height of one of the faces when it's laid out flat. Now if we look at the base and the faces separately, the area of the square base is easy enough. That is just the side length a squared. So we want to work out a way that we can combine the area of these 4 faces together. That is in terms of the actual height of the pyramid, h, rather than the slant height. Well, firstly, what we can do is imagine looking at this pyramid face on. And from imagining this, we can draw up what we would see. This would be our side view looking straight on. We have the slant height, the proper height from the ground to the top, and the side length a. Now what we can do from here is to split this side view in half. And what this does is give us a right angle triangle that we can now make use of, as by using Pythagoras we can get s in terms of h. So we have a over 2 squared plus the height h, also squared, which can be simplified a bit further as a squared over 4 plus h squared. Now from here we can go back over to our 4 faces, and let's consider the area of one of the side faces, as it would simply be defined as the standard area for a triangle, which is half multiplied by the base multiplied by the height. So with what we know, this can be written out as a over 2 multiplied by our expression for s, a squared over 4 plus h squared inside square root. So this will give us the area of one side face, and we have 4 of them. So we just multiply by 4 to give us the area of all these faces together. When we do that, what we get is 2a multiplied by the square root expression. Which is exactly what we have in the formula that we used in the first example. So this shows where it comes from and why it can be used to work out the area of a right pyramid with a square base, provided that we know the height from top to bottom and a side length of the base.